Hi all, once again welcome. So today we will study about the dynamic characteristics of measuring instruments. So you already covered static characteristics. So static characteristics means the input is static or it is changing very slowly. So the characteristics of the system under such circumstances is coming under static characteristics. So dynamic characteristics means the input to the system is changing very rapidly or very abruptly. So such characteristics are called dynamic characteristics. So dynamic means that something is changing with the time. Steady state means there is no change. That is coming under static characteristics. Static characteristics can be classified under steady state. So at steady state, differential equations are not needed. The set of criteria defined for instruments which are changes rapidly with time is called dynamic characteristics. So the change to the input is very rapid. So the instrument must be capable of taking up the changes effectively. So the characteristics under such circumstances is coming under dynamic characteristics. So we have various dynamic characteristics. So those are speed of response, measuring lag, fidelity, and dynamic error. These are the main dynamic characteristics when we talk about measuring instruments. So first of all, let's see what is speed of response. The rapidly with which measurement system responds to changes in measured quantity, that is known as speed of response. That means when a measured quantity or input is changing, how rapidly the measurement system picking up that change, that is, or how fast the measurement system is picking up the change, that is speed of response. So it is an important parameter which shows how active and fast the system is, and also it shows the speed of the measuring instruments in the measurement system. So that is the first dynamic characteristic. The second one is measuring lag. So as the name indicates, every system requires its own time to respond to change in input. This time is called lag. So whenever there is a change in input, depending upon the instruments used in the measurement system, every measurement system will take some time to respond to the changes in input. So that time is called lag, or it is technically called measuring lag. So that is the second one. Now coming to the third one, that is fidelity. Fidelity means the degree to which the measurement system is capable of faithfully reproducing the changes in the input without any dynamic error. That is the accuracy or the degree with which the measurement system is capable of reproducing the changes in the input without any dynamic error. That is fidelity. And the fourth one is dynamic error. That is also another important dynamic characteristic. So dynamic error means the difference between the true value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. That is the difference between true value which is changing with time and the value indicated by the measurement system, provided there should not be any static error. So these are the four types of dynamic characteristics when we speak about measuring instruments. Now let's look why these dynamic characteristics are important. So the static characteristics refer to the result when a constant input is applied. What happens if the input is not constant but is changing? How does the instrument respond? So these two things depends on dynamic characteristics. So that is why dynamic characteristics is also important from the point of view of measurement systems. So let us take an example. We all know a standard thermometer which is used for measuring the temperature in a room. So when we think about the room. The changes in temperature are slowly during the day and night. There is no sudden changes to the temperature happening inside the room. So the standard thermometer must be capable of picking up that changes, since the change is not so abrupt. Now compare this to the measurement of cylinder temperature in a combustion engine. This change is extremely suddenly and by a large amount. So in an internal combustion engine, we all know there is sudden processes taking place and there is temperature changes taking place abruptly. The output from the standard thermometer to this type of input would be useless. Different instruments handle changing input in different ways. So in this case, if we are using a standard thermometer to detect the change in temperature inside the cylinder, that won't be useful. So that is, it is changing very fast. So that's a case of example where dynamic characteristics are coming into picture. So we have to go for instruments which capture the sudden changes effectively. So now to compare the instruments fairly, we should apply the same type of input to each and measure the result. An easily repeatable changing input is required. So in order to compare the response of different instruments to same type of input or different type of input, we have to give the input to different type of instruments and then compare the output. So for that, we have classified the input quantities or input into three categories. So there are three standard types of changing input. That is, input is changing. First one is the step input. As you can see here, the step input, it is changing in a step-like pattern. And second one is a ramp input, which is changing in a linear way. And the third one is sinusoidal input, which is moves like a sinusoidal curve. These are the three standard types of changing inputs. Now the response of different system to or different instruments to this type of standard inputs are checked, and then we will be able to define the dynamic characteristics of different measurement instruments. So first one is step input. So just think of a situation where a thermometer is suddenly moved from a beaker of ice and water into a bath of boiling water. So here we know, since the thermometer is moved from ice to boiling water, there is a sudden abrupt change in temperature. So is this a step change in the input? So we know it's a step change in the input because the temperature is suddenly changing from 0 degree to 100 degrees. So that is a step change or a sudden change. Describe what happens to the reading on the thermometer. So in this case, the thermometer will not be able to produce the accurate reading because the thermometer is not capable of picking up that abrupt change. So that will end up in wrong readings. So the thermometer is not suitable for measuring the change in this kind of a situation. Does it take a long time to get to the new value? So it will take a long time to get the new value, and the result may not be that much accurate. That is, thermometer cannot be used when there is this kind of an abrupt change. That is the case of step input. So next is, this is step input. You can see the input temperature, time. First the input temperature was 0 degree or at the lower value. Then at a particular time the input temperature suddenly increased and again it become constant. So it is a step input and that is changing abruptly with respect to time. Next one is ramp input. For example, a thermometer is placed in a bath of water and ice and a constant heat is applied to the bath. The thermometer reading is recorded as the bath temperature is ramped from 0 degree to 100 degrees Celsius. That is this case. This is a ramp input. Initially the temperature or the temperature was 0. As the time increased, we gradually increase the temperature, not abruptly, gradually increase the temperature, and the temperature increase and reach 100 degrees Celsius. That is the case. So in this case, the thermometer will be capable of picking up the reading because it is not an abrupt change. This change is gradual. So the thermometer will be able to detect the change in temperature from time to time. That is the second type of input. Then the third one is sine wave input. This is the third type of standard input. That is, we usually see a sinusoidal input which is varying over and above a mean line in a periodic way. There will be a specific time period, there will be a specific frequency. So this type of input is the third type of standard input. The laboratory experiment with the LVDT uses this type of sine wave input. So these are the three types of standard inputs used in measurement system for checking the performance of instruments and to check the dynamic characteristics of various measurement system